Hello and welcome to the next lesson. If you haven't subscribed to this channel, please subscribe now. Since we have spent some time discussing what data science is, we should spend some time looking at what exactly data is. First, let's look at what a few trusted sources consider data to be. First up, we will look at the Cambridge English Dictionary, which states that data is information, especially facts or numbers, collected to be examined and considered and used to help decision making. Second, we will look at the definition provided by Wikipedia, which is a set of values of qualitative or quantitative variables. These two are slightly different definitions and they get at different components of what data is. Both agree that data is values or numbers or facts. But the Cambridge definition focuses on the actions that surround data. Data is collected, examined, and most importantly used to inform decisions. We have focused on this aspect before. We have talked about how the most important part of data science is the question and how all we are doing is using the data to answer the question. The Cambridge definition focuses on this. The Wikipedia definition focuses more on what data entails, and although it is a fairly short definition, we will take a second to parse this and focus on each component individually. So the first thing to focus on is a set of values. To have data, you need a set of items to measure from. In statistics, this set of items is often called the population. The set as a whole is what you are trying to discover something about. For example, that set of items required to answer your question might be all websites, or it might be the set of all people coming to websites, or it might be a set of all people getting a particular drug. But in general, it's a set of things that you are going to make measurements on. The next thing to focus on is variables. Variables are measurements or characteristics of an item. For example, you could be measuring the height of a person, or you are measuring the amount of time a person stays on a website. On the other hand, it might be a more qualitative characteristic. You are trying to measure like what a person clicks on a website, or whether you think the person visiting is male or female. Finally, we have both qualitative and quantitative variables. Qualitative variables are unsurprisingly information about qualities. They are things like country of origin, sex, or treatment group. They are usually described by words, not numbers, and they are not necessarily ordered. Quantitative variables, on the other hand, are information about quantities. Quantitative measurements are usually described by numbers and are measured on a continuous ordered scale. They are things like height, weight, and blood pressure. So taking this whole definition into consideration, we have measurements either qualitative or quantitative on a set of items making up data. Not a bad definition, huh? When we were going over the definitions, our examples of variables and measurements, country of origin, sex, height, weight, are pretty basic examples. You can easily envision them in a nice looking spreadsheet with individuals along one side of the table and the information for those variables along the other side. Unfortunately, this is rarely how data is presented to you. The datasets we commonly encounter are much messier, and it is our job to extract the information we want, corral it into something pretty like the imagined table here, and analyze it appropriately and often visualize our results. Here are just some of the data sources you might encounter, and we will briefly look at what a few of these datasets often look like or how they can be interpreted. But one thing they have in common is the messiness of the data. You have to work to extract the information you need to answer your question. Sequencing data, population census data, electronic medical records, geographic information system, image analysis and image extrapolation, language and translations, website traffic, personal or ad data, for example, Facebook or Netflix predictions, etc. So one type of data that I work with regularly is sequencing data. This data is generally first encountered in the FASTQ format, the raw file format produced by sequencing machines. These files are often hundreds of millions of lines long, and it is our job to parse this into an understandable and interpretable format and infer something about the individual's genome. In this case, this data was interpreted into expression data and produced a plot called a volcano plot. A, vol- a volcano plot is produced at the end of a long process to wrangle the raw FASTQ data into interpretable expression data. One rich source of information is countrywide censuses. In these, almost all members of a country answer a set of standardized questions and submit these answers to the government. When you have that many respondents, the data is large and messy, but once this large database is ready to be queried, the answers embedded are important. Here we have a very basic result of the last US census, in which all respondents are divided by sex and age, and this distribution is plotted in this population pyramid plot. Link to the US Census website and some tools to help you examine it will be provided in the blog post for you. But if you are not from the US, I urge you to check out your home country's Census Bureau if available and look at some of the data there. Electronic medical records are increasingly prevalent as a way to store health information, and more population-based studies are using this data to answer questions and make inferences about populations at large, or as a method to identify ways to improve medical care. For example, if you are asking about a population's common allergies, you will have to extract many individuals' allergy information and put that into a easily interpretable table format where you will then perform your analysis. A more complex data source to analyze are images or videos. There is a wealth of information coded in an image or video, and it is just waiting to be extracted. An example of image analysis that you may be familiar with is when you upload a picture to Facebook, and not only does it automatically recognize faces in the picture, but then suggest who they may be. A fun example you can play with is the Deep Dream software that was originally designed to detect faces in an image, but has since moved to more artistic pursuits. That was all for this lecture. See you in the next lecture that will be about data science process.